Let's go.
Did you want to skip lines?
All right, kiddos. 2-6. Continuity of trig functions and inverses. So we start off with a theorem. The theorem basically just says, as long as c is any real number, all right, no complex. There aren't any complexes here at all. Within the natural domain, okay, of the stated trig function, sometimes it does that. Then the following can be true, and these will seem very similar, very obvious. However, technically, before talking about continuity of functions and before getting that special limit property of compositions of continuous functions, I couldn't actually make this jump. We cheated and we made it a little bit earlier just because I wanted you guys to work on AP number 2 a bit. But since trig is a continuous function, sine is continuous in its domain, cosine is continuous in its domain. As long as c is in the domain, then I can take that composition of functions, I can take that out in essence. I can take the limit of the inside argument and then go ahead and simplify. Same thing with tangent, even though you might be like, well, he has a vertical asymptotes. But the theorem says as long as it's in its natural domain, so it just couldn't be approaching a vertical asymptotes. If it was, hopefully we would realize that and say, you're not in the domain, I can't use it. So then with that, a couple more seconds. How would you do the following? Go. How would you do the following? If you can treat or see trig as a composition of functions as long as it is continuous, which 0 is in the domain of sine, how would you solve? Who has yellow? What? Look at you guys all in order. I think I this horrible.
Or better.
Okay, so if I try to take the limit, what do I get?
Keep going.
Since sine is continuous, I can do the following. Which some of you would have thought anyway, because you would have seen the 0 over 0 and said, hey, keep going on the inside part, and we'll deal with sine later. Ultimately, the property of the theorem on the page before, makes it okay, makes it legal to do. So then you're right, it is going to be keep going. I was just showing you how you could keep going, why it was legal to do. Ignore the sine, take the limit of the inside. What do I get? Sine of? Technically, if you were showing all of your work. Why did I still write limit?
Because you're not.
I haven't done it yet, but I'm about to. Because how do I finish? Plug it in. Done. Wait, no, simplify. I can find, no I can't. What sign of -3? Calculator. Do I want you to go to the calculator and get an approximate, therefore somewhat erroneous answer? No. Let's not introduce error as long as we can help it. But what if it was, say, a trig circle 1? Trig circle, unit circle 1. Then you should go ahead, as the AP guys would expect you to do, you should go ahead and solve it. That's back. All right, keep going. So, you could be dealing with trig by just normal plugging in, but if plugging in doesn't work, maybe you can use the property and deal with whatever the argument is, but sometimes it has nothing to do with the argument. There's just no way to simplify, and this is review. You guys, let's see if you have your forever memorized. What is one of the special trig limits?
Sine of u.
No.
Limit as x approaches 0.
X approaches
U approaches 0. Sine of U over U equals 0. 1. Who said 0?
Next one.
Limit as U approaches 0. 1 minus cosine of U over U equals 0.
My ones who are like blah, 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 fail. Okay, so good. So we might be using those, and we've already practiced using those, right? But maybe a few of you guys were like, where did those even come from? Now, I mentioned this back in the day, like 2 weeks ago, 1 week ago, when we talked about it. We didn't really see an illustration of it, and I did want to show you a little bit of an illustration since it comes in section 2.6. It's answering the question, how do you know? Well, Miss Buick told us. Well, that's all well and good, but how did the people that taught me know, and the people that taught them, and how did the books know, the textbooks, and how did, okay, here's how. Squeeze theorem. If there is a limit that I cannot algebraically simplify, multiplying by the conjugate, factoring, simplifying, multiplying by 1 creatively, getting common denominators, etc., etc., etc. You could go to your calculator and estimate and hope that that numerically, sometimes it doesn't work, doesn't happen to you. You guys had that one question, right? Like what problem about the numerical method? You plugged in 0.01, 0.001, 0.001, and it's like, oh, the answer is 1/6. Kept plugging in, you're like, oh, stink, the answer is 0. Numerically and graphically doesn't always work. So therefore, there actually is a way to prove what a limit of a function equals. You should know that answer already. Here's the idea. I want to look for the limit of some funky function f of x. As x approaches c, I cannot algebraically solve for it. It's impossible. Like sine of x over x. Like 1 minus cosine of x over x, which are special cases of my 2 special trig limits. If I am able to identify an upper function over a particular interval that contains c, and a lower function, where's my g? There he is. Then I'm able to make the following. So here's my if. If I can say over a certain interval that g of x is less than or equal to my function I'm trying to take the limit of, which is less than or equal to an upper function, so if, first of all, f is being squeezed between g and h in the sense of one's always below, one's always above, and squeezed in the sense of the two converge at x equals c, which can also be shown as the limit of g is the same thing as the limit of h So if the limits converge at c, and if g is always below and h is always above, then the limit as x approaches c of f of x is equal to that constant as well. For our special limit of sine of x over x, which has then been generalized for sine of u over u. To find that limit as x approaches 0 sine of x over x, they were able to identify the lower function as the negative absolute value of x and the upper function as the positive absolute value of x. which is always below, always above sine of x over x for an interval containing x equal to 0. And then they were able to show that the limit as x approaches 0 of the absolute value of x is the same thing as the limit as x approaches 0 of the negative absolute value of x, which equals 0. Therefore, they were able to say, now to my knowledge, there has not been any question requiring a knowledge or capability of applying the squeeze theorem on any AP test. However, it is definitely an important concept, an important tool that has been used specifically, like right now for you guys, has been used to find both of these important trig limits that make solving complicated and unknown, keep going trig limits possible. It's the foundation, right? It's the two that we're going to use. And there actually is a type of AP question that I can ask you, and it's going to be on the next page. It's a multiple choice one. It requires some knowledge of the squeeze theorem. Let's see if you can do it. Nick, I'll answer it as I get them working on this one. There we go. Nick.
When it says C is an element of A and B, are those brackets?
Parentheses. Because it needs to be in between. It can't be at the end point. So I can't say or including.
Okay.
This requires some knowledge of the squeeze theorem. Because it gives you, oh, S is sandwiched between. And then it asks. Now, for any AP question, if it asks for an answer and you're like, I have no clue how to, they have given you enough. Doesn't mean you'll see it right away, but they have given you enough to solve. You might say, what is S? I don't have a graph, I don't have a table, I don't have a function, but they have given you enough. And it requires some knowledge of the squeeze theorem. Emily?
I'm a little bit confused because isn't the theorem or the trig identity that sine of u over u equals 1, but then p where you use the sine of x equals 0?
No, you're right. Did I fill in the wrong one? Thanks for your question. Which one? I know. Which one? I saw you talk. No, I saw them talking. Are we really starting the burns right now? Seriously? All my burn people from last year, I'm done with you all. All right, come back.
Burn.
That deserves that.
In honesty, gracious honesty. Coming back. Limit as I go to 0 of absolute value, limit as I go to 0 is 0. Problem. Which one did I just prove? I just wrote the wrong function. Oh my goodness. Teachers can make mistakes too. We should too. Shouldn't that actually be encouraging? Because it's like, hey, even the people who have gotten the degrees and the credentials and gone through college can make mistakes. Yeah, I almost did it again.
At least you don't think about paying attention. We need a weekend.
The rest of you guys thought it and just didn't bring it up, huh?
Yeah.
Yes.
We knew what you meant.
Yes.
Anyways, back to the
Killing me, Smalls. All right. We are not bringing back burn for all of you guys. I'm just warning said parties. We're not bringing it back. Because if you know me at all, you knew that wasn't a burn. That was more of a, I'm observant and I saw discussion taking place as I was moving on, and then it was brought up. Here we go. I know that S is in between. Extraneous conversation cease. I know that S of X is in between, right? So I have a lower, I have a higher. They ask me, I say, I have no clue. You told me nothing about S, but they did. So if they're showing it being squeezed, what might I try? Can't take that limit, but I can take I can take, do what you can do. You might not always see it, but do what you can do. See if it helps. What's tangent of 0?
Nobody knows. 0. Just kidding.
At 0, what's tangent?
0.
Just in case you don't want to do the sine over cosine thing. Think about his graph. 0, 0. Oh, tangent of 0, 0. Got it. What's ln of?
1.
I'm writing this in case people don't know it off the top of their heads. We technically have defined that in pre-cal and algebra 2. But if worst comes to worst, e to what power is 1?
1, 0.
E to what power is 1? Anything to the 0 power is 1. Hence why log of 1 is always 0. So, if his limit is 0 at 0, if his limit is 0 at 0, if they are converging, who's going to get squeezed in between? That's a way I could ask the squeeze there. And it's helpful. Alright, moving on. Inverse functions. Let me zoom in because I'm not going to really write anything underneath that, so let's just zoom in. Oh, actually I am. That's going to be an example. Okay, quick review. A function f is invertible if the function is 1 to 1, passes the what again? Pre-cal? Horizontal line test. Right? With inverses, I know the domain of, oh, have I hit this one home? I pray so. What's the domain of f? It determines the range of f inverse, and the range of f determines the Quest Chapter 1, bonus opportunity, homework check, first one that we ever did. All of them had questions on this. From that review material, or just kind of thinking about that review material, you can kind of read this theorem a little bit more intelligently. Summarize it. You don't need to necessarily write all of it. It's not a forever card. You're not going to have to restate it. I just want to make sure you understand the idea of it. If f is a one-to-one function, aka his inverse is a function as well, that is continuous at each point of its domain, then, that's my if, as long as f is continuous and one-to-one, then f inverse is continuous at each point of its domain, so f inverse is continuous at each point of f's range. So the s a little early. Just connecting once again that relationship between the domain of an inverse being the range of the original. And with that, I can get to an example. And this function, I haven't seen much on A/B tests. It comes much more on BC tests. But if I were to ask for, let's look at given. I don't even need to say that. Let's do this. To consider an inverse, I should always look back to the, and since it is an inverse function, that means it has been, the original has been restricted to an invertible or a one-to-one section. So it's not the infinite tangent curve, which repeats over and over and over. Tan inverse restricts, something else from Quest Chapter 1, the bonus. Sine inverse was restricted. So is tan inverse. So if this is my restricted, my one-to-one tan of x, my f of x, question, where is original tangent continuous?
0 and
Careful, not 0 to pi.
negative pi to pi.
Not negative pi to pi. I heard it.
Including.
Including or not including?
Not
Not
including.
Good, because I have vertical asymptotes, right? So we're starting with this, right? That's our tangent. That's our like background information. So how would I get tan inverse? What does he look like? What does he look like?
Flip him over to pi for them.
Okay, flip him over. So he's going to go like, where is he continuous? He's the inverse function of tangent. So we restricted tangent to be 1-to-1 invertible while still containing the whole range. Where is he continuous? Nope, not 1 to -1.
All the way across.
Which is?
All of the above.
Which was the range of the original. Right? Because the range determines the domain, and if he's continuous everywhere in his domain, and he's going to be continuous for the inverse everywhere in the original's range. But if you had the picture, you could look at it and say, oh, he's continuous everywhere. All real numbers, negative infinity to infinity. Just a little application. And also a reminder of what tan inverse looks like. One of those random ones that could come up from time to time. Okay, so let's practice the whole like continuous thing with trig. And I just picked a couple of silly ones. You guys have another few in your homework. But guys, number 1, where is sine of x squared minus 2 continuous?
Can you spread it out? Exactly.
No. Would not help anything. You could. X plus root 2, x minus root 2 doesn't help. Don't think about the whole thing. Think about the inside and the outside. Plugging in, any discontinuities of x squared minus 2?
No.
No problem, right? What comes out of x squared minus 2? Range, all real numbers, right? Well, not all real numbers. I guess there's going to be a domain restriction. But for any numbers that come out, can I plug any numbers into sine? Does sine have any discontinuities by itself?
No.
It goes on forever. So any discontinuities?
No.
None. Why? The domain of sine is all real numbers. So there's not going to be, first of all, there's no problems on the inside. Second of all, so then when I plug in and get out numbers, there's no problems plugging into sine. I'm good to go. Right? How about number 9?
None.
Why none?
It's just the inverse.
It's just the inverse.
It would have the same domain as the top. Wouldn't
The
it?
same domain as the top?
Like all real numbers.
No, domain is the range.
Its domain is the range of the question. What's the range of sine? So this is only going to exist for, there are no discontinuities in its domain. There are none in its domain. However, I should still remember that x will only go between. Last year in pre-cal, you saw a couple times, I think, sine inverse of like 3, and you're like, it doesn't exist. Try to plug it in, doesn't work. Why? Because sine inverse, the inverse relation is only going to go between 1 and -1 for his x's. And more specifically, the inverse is restricted, but that doesn't really matter. He's still going to have the same domain restrictions, which are the range restrictions. Okay, let's get back to something more fun though.
Oh. Oh, totally.
Some of you guys have these types of questions on AP too. You get to practice them some more. Here we go. Limit as x goes to infinity of cosine of 1 over x. Not that you have to write this every time, but just to think through, what's the limit of 1 over x as x goes to infinity? Yeah, he's just going to 0, right? Bottom wins. So what's cosine of 0?
1.
Cool. Limit as theta goes to 0.
The 0.
Did any of you
1,
guys get the
0,
trick for these ones?
3.
However, could you prove it? Yes, you could. Because sine of u over u goes to 1. 1 times 3 is 3. All right, cool kids. We got farther than period 1. The only thing we didn't get to is just a few more fun examples. But hold on, pause. What would you do?
Get it online.
Take this
Plug it in.
Oh no, I can
Pi over 6.
Oh my goodness gracious. What is it?
Oh.
Woo, we're done. All right, you guys finished 2-6. I'll see you on Monday, if not earlier. So, WCC number 1, practice everything. Homework number 9, you can finish it.
Wait, is that bottom number 2?
It's E.
It's a 2.
Okay.
We have to.
Looks like some random thing you made up.
Wait, press
Do we have to do in the introductory WCC?
She can
We'll
No.
need it in
I'll delete it. I'm just showing it.
How do you know that she wasn't asking Danny about that question?
Because I said
Press stop.
Nick Davis, why are you picking a fight?
I'm not. This girl.
Like to
She
voice
hates
her
me.
opinions.
Who hates you?
Nick,
She
Nick,
doesn't like to
she
voice
doesn't
her
like to voice her opinions. She doesn't like to voice her
Don't do
opinions.
it. Nick, no one hates you.
Bye, guys.
Adios.
Are you not gonna come in?
Oh, sorry, I was waiting for her.
No, you're cool. Nick Davis, bye. Go have lunch. I'm finished. No, it's not finished. You just need a break.
I have a question.
Yeah.
Wait, so for this one, do you use
Inverse relation just flips it and goes.
But wouldn't it be,
But restriction is the principal branch.
wouldn't it be the other one? Without the one over
That's 1 over sine.
Oh.
That's 1 over
In
sine.
my head, I was like singing it, and then all of a sudden it's like outside my head, and I was like, that just happened in my room. It was funny though, because I was sitting there, and in my head I was like, and then like outside, as I was like singing, I hear like, and I was like, my head.
You're missing signs.
Crap, I
That's
forgot I
like
had
1
to buy
over
lunch.
infinity,
Shoot,
which
that's
goes to
rough.
0.
Just leave me. I'll reach you.
And then cosine of 0 is 1.
Oh, good.
You too, because I didn't mean to start again, but I know like one of them was literally popping out because I could tell the other day she was quiet and you voiced
Good.
I'm going out to Moto for
Back.
Zach?
Hold on. Emily, do you still have the grid code from PSI? Okay. I think. I'm actually switching. And it's not going to make a huge difference besides it'll be better to go through PSI. When you go in, you can add a group code. And you can add the code to that. And then I'll leave.
I have a question.
But Emily, no, I really truly do apologize. Just, I know, but I want you to know that what normally wouldn't be a real like that one blows out of proportion all the time, and so I apologize. And I need to watch. I need to watch myself. So.
Is you gonna be in here?
Danny, you didn't click on the picture. Right there.
No,
Hey,
mine. Are you gonna?
wait,
Are you gonna?
Hold on. Did I do something else?
No, I was just wondering why a G bus and A to the amplified bus.
They found that in the picture on the bottom.
That's why I never did stuff. Why don't you choose those upper level?
Other people's points harder than I did.
I'm wearing a jeans and a sweatshirt.
Which is why you're not going to get up to shoes. It's more the understanding that it can't.
Okay.
And I mean, that's a
All right.
I'm sorry.
No. Totally fine.
All wearing
I was
jeans
gonna
sweating.
actually jump as well, and it's so that's
No, it's okay. I meant to
I was
bring. I had
sweating
something
in
on
my
my
bathroom.
homework. I thought that I brought to school, and I ended up bringing
Alright,
all
I'll
of
see
the
you later.
packets.
Later.
So I had my homework and left the one that was my homework at home. So I have to rush home and finish that before my class.
It's more like
So
here's where
I
it came from. They figured out this,
gonna
and
buy
I'm
lunch
not
today,
use that.
and I completely forgot. And so now I'm
Okay.
I'm just gonna naughty lunch.
Oh,
There's no point in
Okay,
running.
thank you. I'll try to find out.
Right? Totally not.
Hey,
I'm like,
Chels.
Totally not. Sorry,
Okay.
I wasn't
How
sure.
are you? Doing good.
Do you remember me asking you to get lunch last night?
All right
Alright,
then.
guys. Happy lunch tonight.
Possibly.
And Lisa Vino thinks I need to do the ice bucket challenge.
I did not
I
say her.
also needed you. I was supposed to last night with Megan and Karen, but
By the way,
communication fell through the
this is
cracks.
not okay because we definitely talked about not doing it.
And I heard this once you did it, and I was like, you weren't supposed to anyway.
She got on me like 10 times though. So.
So many people. That like rounds down to 0. So.
No, it doesn't.
I'm not too smart.
We should.
Yeah, who should I go to last night?
Is your period in?
Most of my life got this. Which just makes me think. All summer people have been scrolling past the pictures and like, not worth it.
I wouldn't tell anyone that, but
Not worth the double click.
it's like, it's unique. Makes you think like,
a little bit more.
I got Kylie two burritos one time, and she barely ate one of them, and I already finished both of mine.
What's happening?
So
See, I have these briefings right here. She's not gonna finish both.